We have the fabulous Jeff Lee with the town of Gilbert, who knows all things irrigation. He is going to be your speaker today. Please take it away, Jeff.
Good evening, everyone. As Joe said, I'm Jeff Lee. I work with the town of Gilbert Water Conservation Office. So tonight we're going to be talking about what I'm calling maximizing your irrigation. So this is taking your irrigation system and making it better so it's more efficient, so it applies the water more evenly, so you don't have to run it more than you should to cover up those inefficiencies. And don't worry, this is not going to be just a strict PowerPoint presentation. I will be dropping out and turning on my video to show you actual pieces of irrigation so you can get a better look at it. Pictures are great, but sometimes seeing the real thing is better. Unfortunately, with our current situation, normally when we do this class, we actually pass those pieces around so you can actually get to touch them and everything. So let's talk about maximizing our irrigation. And come on, there we go. So we do like to talk a little bit about our reservoirs and what we've got here. This is Lake Mead from all the way back in about 2001. So it was about 50 feet low. We're at about 100 feet lower than full capacity right now. And these reservoirs are how we get through droughts. Other areas of the country don't have these large storage capacity reservoirs, so they go in and out of drought as far as a water supply drought much more quickly than we do. So we do have to understand that drought is our new normal. We've been in a drought, long-term drought since about 1998. There's been a couple wet years in there, and that is typical of long-term droughts, but we really want to do everything we can to keep it in the reservoirs, because we don't want this, which is Canyon Lake with a nice shot of Four Peaks in the background with some snow. We don't want it to turn into this, which is also Canyon Lake with Four Peaks in the background. And for total honesty, this is not a drought event. This is Salt River Project needed to do some work on the dam. So they had to lower the water in that reservoir and then service through Saguaro Lake, which is just downstream of it. But that's a scary sight to us water people. So when we're talking about our irrigation, efficiency is everything. And basically the way people cover up that inefficiency is they just overwater. Everything gets fixed with the plus button on the timer. So on average, Arizona landscapes are overwatered by about 2 to 5 times. And that's of course the average. There are a lot of people out there who are actually pretty good about how they're watering their yards. And then there's some people that are so horrible at it, they actually skew the data for the rest of the people. So some of this is caused by poor irrigation systems and some is caused by poor management. Very few people understand how to set up proper watering schedules. So I encourage you to get in touch with your Scottsdale Water Conservation Office and get that fabulous landscape watering by the numbers brochure so you can make sure you're applying the right amount of water. So oftentimes what we're seeing though is it's actually a combination of both. And even on our commercial systems, those landscape contractors will recognize inefficiencies in that irrigation. And what they'll do is they will cover it up, and actually they usually overreact. They kind of go overboard. So there are 2 parts to efficiency going on. Obviously there's the hardware. There's the sprinkler heads you have out there. There's the controller capabilities and how well it's being programmed. And of course your drip emitters, what kind you're using, where they're at, how many you have, all those good kind of things. And then of course the hard part of course is the software, and that's the person pushing the buttons at the irrigation controller. So again, get that landscape watering by the numbers brochure. It helps. It's a really fantastic guide. Gets you to put the right amount of water on based on your landscape, not mine, and based on your irrigation system, not mine. Everyone's irrigation system is a little bit different. So that brochure really gets you to dial it in for what you actually need. So when it comes to the hardware, the efficiency is going to be based on the design and how it was installed. Unfortunately, many times you get less than what you should. So the other part is the software. It's based on how the schedules are created, how often they're adjusted and managed. And that means you. It's up to you to take care of that part. So let's talk about drip irrigation and some of the things we can do to make sure it's operating at the optimal efficiency. And one big thing we have to remember is drip irrigation is not only a low volume irrigation system, it is a low pressure irrigation system. Drip irrigation systems are happy operating usually between about 20 to 30 pounds of pressure. So that means we want to put that pressure regulator on there. And let me see if I can't do a little, where's my annotate? I thought I had a little button here so I could draw something. I'm not seeing it. All righty. Never mind. Oh, I got the little button down here. I guess I can do that. So let's do the pen. So you'll see on this guy, you see this is good between 2 to 20 GPM, and it's actually a 30-pound regulator. So let's click off of that. Okay. And every time I go in to use that annotate, it doesn't want me to use my mouse anymore. Okay. So one of the things you can do is test to see if you've got it a pressure regulator that's actually operating at the proper pressure, or worse yet, unfortunately, we see many drip irrigation systems that do not have a pressure regulator installed. So we've got issues where you've got maybe no regulator, a malfunctioning regulator. If it's installed, it may be the wrong one, or it's not functioning properly anymore. Or you could have some pinch tubing somewhere along the line where you've got good pressure at the beginning of the system, but when you get out to the end of the system, you have no pressure left. So we'll cover some of those things specifically in tomorrow night's class. So what I'm going to do is I'm going to stop sharing and show you how you want to test your pressure there. So can everyone see me? Okay. So when it comes to testing water pressure, we can all test the water pressure at our house just by getting a pressure gauge that hooks onto a regular hose faucet. And the way this helps you, let me take this off of here real quick, is if you're using this style of end cap at the end of your drip lines, the thread on these caps is not pipe thread, that's hose thread. So by simply unscrewing that cap there, we're going to screw this on here and turn that system on, and then we'll know what the pressure is at the end of the system. If we're starting at 30 PSI with our 30-pound regulator, a properly designed, good operating system should still be at 27 pounds of pressure minimum. If it's less than that, you've got some problems out there. So real quick, while I've got the video open, let's kind of show you kind of what a typical drip irrigation valve system would look like. So here we've got our irrigation valve. Your drip system should also have this filter to make sure you're protecting those emitters from getting clogged up. And then of course, there's our pressure regulator. And you can see this one is a 30-pound regulator. And then they also have the range that they're supposed to work in or able to work in as far as how many gallons per minute. If you're below that range, it will not regulate the pressure. If it's above that range, it'll over reduce the pressure. So you got to make sure you've got the right one in. So that's a very common one we see out there, but they're not always like that. Sometimes, this is also another pressure regulator. All right, so let's go back into our presentation here real quick, and I'm going to stop my video so you're not looking at me in the corner there. There we go. Okay. So the other thing that's we see a big mistake on with these drip irrigation systems is people use the wrong emitters. They don't use emitters that do what's called pressure compensation. So your cheap emitters are nothing more than a hole in a piece of plastic, which means the higher the pressure, the more water comes out. The lower the pressure, the less water comes out. And let's see if I can use my little annotate screen here. Where's my mouse? There we are. Oh, I've already got the little screen up there. So let's see if I can draw it. This is a tiny, tiny little dot I'm trying to look at. So you'll see on this 1 gallon per hour emitter starting at about 15 PSI, all the way up to 15 PSI, it is still putting out only 1 gallon per hour or very, very close to it. Whereas you got those cheap emitters like these over here, you'll see as the pressure increases, the water consumption is going up. So this 1 gallon per hour emitter right here at 15 pounds of pressure is putting it up, but already at 25 pounds of pressure, it's getting much higher. And notice this chart from this manufacturer does not show you what happens all the way out to 50 pounds of pressure. And the reason for that is you're not supposed to run them at that high of a pressure. So these cheap emitters end up wasting water because they're just putting out way too much. They cause you to not be able to water deeply because when you apply the water too quickly to our soil, it just runs off the surface. So that's how these cheap emitters kill plants. And actually these cheap emitters are only pennies cheaper than good quality pressure compensating emitters anymore. So real quick, let's show you a pressure compensating emitter. When your drip system is running, it's supposed to look like this one on the left. You're supposed to see individual drips of water at 1 gallon per hour. They should be constant but separate drips. This also over here is a 1 gallon per hour emitter running at the same pressure as this one. But because it doesn't do that pressure compensation, now you see the water's coming out in a stream. So that's actually probably putting out about 10 or 12 gallons per water. And the other reason why that's important is if you're using our watering by the numbers brochure, we tell you how to water a plant based on its size and tell you how many gallons of water to give it. These guys, you don't know how much water is coming out of there unless you measure each individual one. And some of your bigger ones can be putting out these streams of water, but at the ends, they might start looking more like this. So who do you set that watering schedule for? So there we go. There's my button that I wanted. Okay. So you also want to make sure you've got enough emitters for the plants. When that landscape first gets put in the ground, they put in enough emitters for what those plants need at that time. Nobody ever looks ahead to put in more emitters for what those plants are going to need at maturity, and nobody moves them out and away, which we'll also talk about. So this is kind of a nice little table here. This table I actually copied right out of that landscape watering by the numbers brochure. So again, I recommend you get that. So you'll see if I've got a large shrub that's 4 to 6 feet wide, I want to have 2 emitters that are each putting out 2 gallons per hour. Yet 99% of those landscapes we see out there, that poor shrub still has that 1 gallon per hour emitter still put at the base where it needed to be when the plant was first put in the ground. So let's erase that. There we go. Okay. So let's also talk about putting the emitters in at the right place. One thing you have to remember with irrigation is you need to get the idea that you're watering plants out of your head. You are not watering plants, you're watering roots. And that's why that emitter is placed right at the base of the plant when it's first put in the ground, because that's all the roots it has from the nursery container it came in. But especially with your woody shrubs and trees, you want to start pulling those out and away, usually about 6 months after installation, and then just kind of keep up with them as the plant grows. So remember, we're watering roots. So in our scenario here, that original emitter down here is doing nothing for the tree because these are the large woody structural roots. What's going on is with your woody shrubs and trees, all the water absorption happens at the ends of the roots. And one of the things we always focus on, we tell you to try and keep those emitters kind of even with what we call the drip line of the tree. And we call it the drip line because when it rains, that's where the water kind of drips off the edge of the canopy. And if you think about what's going on here, think about being stuck out in the middle of nowhere and it begins to rain. Everybody naturally gravitates to under the trees. And that's not because it's wetter under there, it's drier under there. So what's going on is all this water that's hitting the tree canopy from rainfall is dripping off this edge. In nature, the majority of your water absorbing roots are going to be here. And the more you mimic nature with that irrigation system, the more successful you'll be. Trees fall over because people do not move those emitters out away from the base. Now, sometimes you get lucky and the tree ignores you and it grows the roots anyway, but many, many times we see it time and time again. I see mature sized trees go down and I can tell you what size container they came from the nursery in because they just didn't bother growing roots. They didn't need to. The emitters were always right at the base. Now, when it comes to adding in more emitters, let's go ahead and start my video and stop sharing. So very commonly what you're going to see for many of the way your emitters are installed. Let me pop one in here real quick. So typically they're going to use a standard connector. Now sometimes people will put the emitter directly into the tubing and then your large poly tubing and then the spaghetti, the 1/4 inch tubing will come up and just be empty at the end. But in most cases, the preferred way to do it is to use that 1/4 inch connector and then have your emitter at the end of that line up above ground. So that way, when it clogs up, you can just cut it off and put a new one on rather than digging back to your larger line. So when it comes to needing to move these emitters out, it is just a matter of, and don't do it this way, I'm cheating. You want to actually cut that off so you get to clean spaghetti tubing, but just use another one of those connectors and add on some more line and put your emitter back on the end, on your new end, which is a little bit further away. So if you're going anywhere from about oops, I kind of fell off there. If you're going 4 to 6 feet away, you can do it with this 1/4 inch tubing, but sooner or later, what you may want to do is put in a T-fitting on the larger tubing and then run some of the larger tubing out into that new area that you want to apply that water to. Okay, let's go back to our presentation here. So off the video, share the screen. There we go. There we go. Okay. So sometimes people have done a bad design and they just ran that tubing too far of a distance. Whenever you move water through pipe, you're losing pressure. So if you go too far, you won't have enough pressure at the end of the line. So in one case, if you're lucky enough, you might be able to actually loop it. So here in my explanation here, now this is just a drawing that we use on a regular basis. So this probably wouldn't be too far and it's not too many plants, but pretend it's a much larger yard and there's a lot more plants there trying to pull more water through the line. They may have discovered that they don't have enough pressure at the end of this line. So what you may want to do if you can is just go ahead, and it's hard to see with my dotted line here, but you'll see what we did here is we actually connected it. So now the water coming to this plant is coming from the irrigation valve from this direction and also from this direction. So if you have the ability to loop them, go ahead and do that. And when it comes to putting in a flush cap, you don't have an end on this line anymore. So just go ahead and put one anywhere you can, furthest away from the valve as you can. Another thing you can do with too long of a tubing run is just lower the flow rate. The faster you try and push water through pipe, the faster you lose pressure. So what you're going to do is you're going to try and slow down that water by using smaller emitters. And the way you're going to compensate for that is to use longer run times. So also get rid of these micro bubblers. People call these adjustable emitters. They are not. These are what you want to be using for flower pots, flower beds, and vegetable gardens and things like that. But the more you twist this guy open, the more water comes out of these slots. And the reason why you do that is because in our clay soil, a 1 gallon per hour emitter, as it penetrates into the soil, because it is a tight soil, will get pulled sideways by capillary action. You don't get that effect in that loose, fluffy potting mix we use in our potting for our potted flowers. So we have to apply the water faster. So the other thing is you can overtax the hydraulic capabilities of that tubing very quickly with these micro bubblers. A resident in Gilbert called us up for some assistance, not because she was concerned about her water use, but because she was very mad about how little water pressure she had. So she had about 30 of these guys, all 1 foot apart and about 40 feet of tubing. And she went to the very end and she actually completely unscrewed that cap and the water just barely oozed out. She was trying to draw so much water so fast through that tubing, she lost all her pressure in only 40 feet of tubing. So what she needed to do is find a different way to deliver the water to her herbs. By slowing the water down, then she had enough pressure left out at the end. Okay, one valve wonders. It's unfortunate, but we still see them on a regular basis. This is where you get one drip valve for everything, ground covers, trees, and shrubs. And you do want to water them differently. You want to water your trees deeper than your shrubs, which means a longer run time. And because you're giving this tree a bigger deposit into that root zone, it has a bigger bank account, it goes longer in between paydays. So not only do your trees get run longer, but they get run less often than your shrubs. So you could split it into separate zones if you're willing to go through the expense and the work to do it, but it is very hard and very expensive, especially on existing landscapes. So at this point, what you may want to consider is just manipulating your water delivery at the individual plant locations. So more high flow emitters around your large plants like your trees. So you may have 6 2-gallon per hour emitters or 10 2-gallon per hour emitters around your trees, and then only 1 2-gallon per hour emitter on your shrubs. You can at least balance out the runtime that way. You're still going to water your trees more often than you have to because you have to water at the watering interval that the shrubs need. So less lower flow emitters for your smaller plants. So let's look at how we measure efficiency on drip irrigation. And I don't want you to get hung up on this, and remember how we do this. This is how certified landscape irrigation auditors look at irrigation, but I'm showing you this so you can get an understanding of what happens within efficient systems. We measure it in what's called emission uniformity, and that is how evenly the water is delivered through that zone, emitter by emitter by emitter. So we go out there and we catch the water from different emitters along that zone. And then we take the average of all the cans and divide it by the average of the lowest quarter. Again, don't try and remember that. Just kind of look at those cans there. With the drip irrigation system, the uniformity should be very high. So all those cans should have very close to the same amount of water in it. So what this means in the real world is you've got, this is actually a real life situation at someone's home. A zone with some desert shrubs on it. They were using those cheap flag emitters that don't do pressure compensation. So it was really drawing a lot of water in gallons per minute through there. And the application rate, we can do those calculations. Again, don't worry about how we did that. But with the kind of information about the shrubs and our historical weather and the efficiency of that system, we could actually calculate out to keep those shrubs alive. It was going to take a little over 142,500 gallons a year. So what we did is we got rid of those bad emitters. You'll see that flow rate, how much water we're pulling through at a time is greatly reduced. Our average application rate, emitter by emitter by emitter, actually came up a little bit because there wasn't so many of those that were putting out too little water, and our efficiency went way up. And by using that same formula with historical weather, now we're only talking 21,698 gallons a year. That's a savings of almost 121,000 gallons, but people don't realize this because you don't get a water bill once a year. You get it every single month. So you're taking these little bites of all this excess water you're using in little bites across the year. So let's talk about sprinkler irrigation. Looks like we're doing pretty good here. We've got about 35 minutes left. This is the first time I've tried shortening this particular presentation down to an hour, but I think we're going to get there. So for sprinkler irrigation, that efficiency is going to be determined by the sprinkler heads and the nozzles that you're using, how the heads are laid out in the yard itself. Make sure the spacing is correct and what pressure they're operating at. Very, very important. And we're going to talk a little bit about that. So now we're going to talk about measuring the efficiency for sprinklers. So if you follow our watering by the numbers guideline and you do have some grass out there, what you're going to do is you're going to put the tuna cans out there because they have flat sides and flat bottoms and straight sides. And you're going to run the system for 15 minutes and you're going to measure the water in each of the cans and you're going to get the average. That gives you an average precipitation rate, how fast the water is being applied by that sprinkler system. And this varies widely by sprinkler system because of things like heads, nozzles, and pressure. So I know people want to be helpful and tell you how many minutes to run your sprinklers, but if they don't know anything about your sprinkler system, they can do a lot more harm than good. To give you an example, the sprinklers I use, it's a specialty nozzle that applies the water very, very slowly. I run my sprinklers for an hour and 15 minutes, but I'm still delivering that 3/4 of an inch of water that I'm after, where your system might do it in 12 minutes. Big, big difference on these sprinkler systems. So once again, don't try and remember how us certified irrigation auditors do it, but we don't want to show up at a commercial site with a bunch of Friskies and Whiskas cans because they'd never take us seriously. So we use these really scientific looking graduated cylinders, but we're doing pretty much the same thing. We're measuring the water, how it fell in the area that those sprinklers covered, getting that average depth. We just take it one step further. We measure what we call distribution uniformity. So once again, we're looking at how the water fell in those cans across that area. Don't bother worrying, don't remember that formula that we use. So there are some industry standards from the Irrigation Association out there for minimal acceptable uniformity. how evenly the water is applied by these different types of sprinklers. So your regular pop-up spray heads, 55% is an acceptable uniformity. They are actually the least efficient way to deliver that water out of current sprinkler technology. The rotor sprinklers, those ones that rotate back and forth with those big streams on those big yards, those are generally more efficient. So they're going to be more up at 65%. And those are low quarter DU numbers. Don't worry about that. We also teach these classes to irrigation professionals. So you also want to make sure you're getting head-to-head coverage. So people will say, well, according to the design, I should use 12 sprinkler heads, but if I stretch them out so I'm not putting them as close together, I only need to use 10 sprinkler heads, and I'll save myself $10. You end up paying thousands of extra dollars in the life of the irrigation system to cover up that inefficiency. You always want the water from one sprinkler head to reach over towards the next. And some software that irrigation designers use, we can use some test data. This is a big sprinkler that they use on the golf course. You'll see what they've done is can by can by can, as they measure in the area that that sprinkler covered, that's how the water fell. So really what you're trying to do is making sure you're using another head that just mirrors that. And I probably won't be able to do it very well, but you'll see it kind of drops down like that. So at the end, we're trying to get that as even as possible when you add those two together. It doesn't happen. You'll never get 100% uniformity. But this is also a real important thing to realize is, let me get rid of those little lines there, is make sure your sprinkler heads and your nozzles are matching. So we can get several different manufacturers' sprinkler heads that throw the same distance as this particular one. But this pattern right here is very different based on how they designed the nozzle. So on those large commercial systems, they lose a ton of their efficiency over the course of years because every series of next landscape contractor that comes in that gets that maintenance contract, they have a sprinkler head that they like to use. It's their favorite head. It may not be the one that was originally installed. So by the time that irrigation system is 10 years old, you've got every brand and a bunch of different models of sprinkler heads out there, and they've lost anywhere from 10 to 20% of their uniformity, which does not mean 10 to 20% more water. That means 20 to 40% more water. So make sure you're using matching heads and make sure you've got that spacing right. So what we want to see is we want to see the water from this sprinkler head reach over to this one. We want to see the water from this sprinkler head reach all the way over to that one. So I'm going to show you a piece of software here, or how you want to check this out to look at your head layout and spacing. And I'm going to make it real easy by doing a simple rectangle here. Draw out the wand to scale. Use a computer program if you have one, or just draw it on a piece of paper. And then you're going to draw where the sprinkler heads are and actually draw the coverage. So if you're doing this on paper, you're going to have to find one of those good old-fashioned protractors to mark down where the water from this sprinkler head is actually covering. And you'll notice we're a little short between here and where it should be reaching with that sprinkler head, here, and also the distance between here. We're not reaching those other sprinkler heads, so we've lost that head-to-head coverage. So what this looks like with some software that irrigation designers can use with test data, they can actually plop those heads in there at that spacing, and it'll provide what we call a densogram. The darker areas are where more water's falling. The lighter areas are where less water's falling. And you see some pretty uneven coverage there. And it'll actually calculate out what that uniformity is likely to be. So that's only 43%. So that does not meet minimum standards. And one thing about these tests is they're done inside at perfect pressure in a zero wind environment. So in the real world, the uniformity of that system is actually going to be quite a bit less. So you also have some other weird things going out there where people will have these unusual shapes. So in this case, if this is the back patio, so they've got their backyard play area there. For some reason, they insist on doing this little dog leg over here, and then they'll throw one sprinkler head in the corner right there. But you'll notice now this head is reaching to that one, but it is not reaching anywhere over here very well. And this head is not reaching over here very well. So when we throw it back into that same software, what it's going to look like is this. So now you can really see just how light the water coverage is in that area. And what that means in the real world is when you're trying to trim down your run times, the grass in that area starts turning brown. So what happens is people start turning it up, and then that means these areas that we're actually getting pretty adequate water, when you turn that up, now these areas are really overwatered. So the more even you get that water application, the less time you have to run it. And also in this particular scenario, the real reason to have grass is to have a play area for the kids or the dogs. How much playing is actually going to happen on that strange little dog leg? Just cut it off and be done with it. Okay, let me get rid of my little drawings here. Okay, so that's already down to a 35% uniformity, which in the real world, you're probably talking about 27 at best. That means you're running that sprinkler system 3 to 4 times longer than it should be if it met acceptable standards. That's a lot of water at the end of the year. So one of the things you can also think about too is for years, a nozzle was a nozzle was a nozzle. Everyone uses a spray heads on the small lawn areas, and it just has a slot where the water comes out. But over the course of years, there's been some new nozzle technologies that come out that actually are a lot more efficient. This one is actually quite old. This one has been around for a long time. It's made by Rainbird, and it's called the U series. Some old timers may remember the old brass nozzles where they had this slot where the water comes out at an angle so it reaches a distance, but they also have this undercut. That's what the U stands for. So the water comes straight out at that. So it actually waters more evenly or gets better coverage in that mid-range, which spray nozzles are very, very terrible at as far as how they apply the water. So those right there can increase your efficiency up to 10%. Another one that came out probably about 5 to 7 years ago or so is made by Toro, and these are called their precision spray nozzles. So instead of a slit, when you look at the nozzle, it's got this little silver piece. Toro calls it a chip. So what's going on there is when you run it, it actually looks like a normal spray head, but that's not what's happening. It's actually flinging the water as it exits the nozzle back and forth. And what that does is it forces the water droplets to break up more and fall in that mid-range where these spray nozzles are just not very efficient to begin with. And then I'm going to show you one more nozzle, and then we'll show you kind of the sprinkler heads and how you put these on. So what came out probably, gosh, we're probably at about 16 years ago now, are what we call stream rotors. So the stream rotor has these multiple rotating streams. All these guys little turn. And actually people that don't understand what's going on with the technology, a lot of people prefer them because they just look so pretty when they're running. So each one of those streams is slowly rotating around. And when it comes to sprinkler nozzle technology, stream rotors have the highest potential for that uniformity, how evenly they're applying the water out there. They also have another great benefit is where they're applying the water much more slowly than a standard nozzle. So now instead of 2 inches per hour, which is really hard to do on a clay soil, you can only run that sprinkler system at 2 inches an hour for 2 minutes before you have runoff, but you don't get any penetration. So you need to do 6 of those cycles in order to get the water deep enough, and very few timers have that capability. Whereas these apply the water much more slowly and it's going to soak in. You're not fighting that runoff so much. Also, per nozzle, they use less water in gallons per minute than a standard spray nozzle. So that affects how fast the water is being applied out there. And you can also get them to throw farther. So if you're using these on the Hunter brand, you've got to know which ones of these patterns you're using. And then they also have 3 different series. The 1000 series kind of goes from 8 to 15 feet. The 2000 series kind of goes out to about 20 feet. And the 3000 series goes out to about 30 feet. That means just by popping one of these nozzles on a standard spray head body, you can get that water to throw all the way out to 30 feet. And at such a low application rate and a low gallons per minute, you're going to be able to actually do that. So let me see here. Let me go ahead and pop out of the presentation here real quick. Stop my share. Okay. So yeah, your standard sprinkler heads are usually connected to the pipe on a riser. And then they've got their standard pop-up stem. And I actually already have one of those rotator nozzles on here. So when it comes to replacing a nozzle, let's see which one this is. So I don't know if you can see this with this video camera, but that's a standard nozzle with one of those one slots. Whereas that U-Series one has that secondary slot down there. So it's throwing out the water also in a flat trajectory to cover in that mid-range area. So these nozzles do come with screens. Use the screens. They're going to protect your nozzle from being clogged up. So just by swapping out a standard spray nozzle with one of these U-Series, you can pick up about 10% efficiency, and they may not always line up exactly the same way if you're up against the edge. Almost all of your sprinkler heads nowadays allow you to turn that stem inside the body. So you can, after you turn it on, get that lined up perfectly the way it should be. So what's going out, here's one of those Toro Precision sprays. And there's that little silver piece, what Toro calls a chip. My camera does not like to focus very closely. But again, what's going on there is, I think Toro has a video on their website when they throw these spray heads, these nozzles under a strobe, and the water's doing this when it comes out. That's getting those water droplets to break up in that mid-range for you. So with the stream rotor nozzles, what's going to happen is this little guy, when it turns on, it's going to pop up on the stem. And then that little piece right there is also going to pop up. And unfortunately, I don't have a good close focusing camera, but there's little grooves in here. And then this part, this very top part, slowly spins around. So there's a Hunter version to this, and there's also a Rainbird version to this. They apply the water at different rates. So whichever one you want to use, keep them matched up. These are about a little under a ½ inch per hour. These are a little over 6/10 of an inch per hour. And that little bit of a difference makes a difference. So keep everything matched up there. Okay, 20 more minutes. Okay. So let's go ahead and turn off my video and reshare my screen. You know, since you're recording this, I should probably share the screen before I turn off my video. It just occurred to me. Okay. There we go. Okay, so you remember that 20-foot spacing where it will look so uneven as far as how it watered? Because your typical spray nozzle, you can only get to reach 15 feet maximum. All we did in here is we actually had real nice even spacing. They were all at exactly 20 feet apart and 20 feet apart. So all we did is we threw in those new stream rotor nozzles that throw 20 feet. And now we are super much more even than compared to where we were before. So we went from a 43 DU, I think it was, up to a 78% with nothing more than changing out the nozzles. Now, a lot of people that try those stream rotor nozzles, I've heard people say, well, I didn't like them because my grass turned brown. And I said, well, how long are you running them? And they said 10 minutes. Well, if they only apply water at ½ inch per hour, and you want to apply 3/4 of an inch to your grass, that means you need to water them an hour and a half. But because they're using less gallons per minute, you actually still use less water, and you get much more even coverage on the grass. So what this means in the real world between those two systems, there's that first one with those standard spray nozzles. The second one where we put in a much better nozzle, didn't have to do anything else to it. So the old system was applying water at a very low rate for spray heads, and that's because that spacing was stretched out. So there were so many weak areas that we measured that it actually pulled that number down from where it should be. So that very low uniformity to water that grass for a year is going to be 98,961 gallons. With our maximized system, by just swapping out those nozzles, see how slowly those that water's being applied now comparatively. That's why you run them for longer, but now it's being applied at a much more even rate or more even application in the area that it covers. Now you're talking 47,784 gallons a year. That's 51,000 gallons a year on a lawn that's only about 1,600 square feet. So it just depends on how much grass you have. I mean, that's not a super huge lawn. It's bigger than mine, but it's not bigger than some of the lawns that we see out there. So it's just amazing the amount of water just by changing these out. But again, let's remember, it's not just changing them out, it's also changing your watering practices to account for the fact that you have a much more efficient irrigation system now. So there are some utilities in California that have been studying this, and they're giving out these high efficiency nozzles by the bushel and they're looking at the water use and it's not changing. That's because people are not changing their watering practices now that they have more efficient irrigation systems, which means really what's going on is they're just overwatering more efficiently or more evenly now. So do make the changes when you make your system better. So let's talk about pressure. If you're using a spray system, I would bet 98% of you have way too much pressure hitting those nozzles. They only want to operate at 30 pounds of pressure, kind of like your drip systems. Rotors want to use a little bit more pressure, and everyone thinks more pressure is better. So one of the things you can do is install a pressure regulator at the valve, just like you do with your drip zones. If it's already installed, now you've got to dig up the box and cut the pipe so you can put everything back together and rebury it. You can buy a valve with a built-in regulator or an add-on piece that will help you regulate the pressure. Really, the best way to do it is to buy sprinkler heads that have built-in pressure regulators. So let me show you kind of what's going on here. So let's turn on the video and stop our share. There we go. So in many cases, when you look inside the valve box, if it was done typically, and at least correctly for your drip systems, you'd have a filter and a pressure regulator. So you know that's your drip valve. And then usually what's going on is the sprinkler valve is just the piping coming in and out. So you can install a pressure regulator after that valve, but again, make sure that flow range is right for your sprinkler system. If it's not enough, it will not reduce the pressure. If it's too much water going through there, it'll actually reduce the pressure too much on you. So one of the brands of valves out there, this valve is made by Hunter Irrigation. And you can buy this little device that goes under the solenoid. The solenoid is the part with the wires going on. So we would just unscrew that solenoid and then screw this piece on. And this you can buy in either preset numbers or the one I'm showing here. This is actually an adjustable pressure regulator. So if you have this valve, you can easily install this without digging anything up. So this works out pretty well, especially with small sprinkler systems, because you're not traveling so far of a distance. You shouldn't be losing too much pressure between the valve and your last sprinkler head. But honestly, the best way to do it is all the manufacturers out there make sprinkler heads with pressure regulators. Toro was nice enough to give me this clear molded body here. But you'll see this guy has a little pressure regulator built right into that pop-up stem. And what that does is it puts every single nozzle at exactly the right pressure. Now these sprinkler heads that come like this are about $7.50 to $8 a piece without the nozzle. Those very expensive stream rotor nozzles are another $7 to $8. So now you're talking $15, $16 per sprinkler head. But I promise you, if you start watering for your new increased efficiency, you will get that money back, especially with pressure regulation. I've seen systems out there where they're probably losing 50% of their water just through that high pressure misting that's going on. That's water that's blowing away, never touching the roots of the grass. Yet the grass is perfectly green. They fixed it with the plus button on the timer. They're running that system twice as long as they should. And at the end of the year, it's twice as much water as what it needs. Now, as far as measuring the pressure, as far as what's going on with your sprinkler heads, there's all sorts of weird contraptions and components you can buy to mount this on the pop-up stem and then put your nozzle on. You don't need any of this. All you've got to do is turn on your sprinklers when the sun is lower in the sky and make sure your sprinklers are between you and the sun. If you see that fine cloud of mist drifting away, you know you're at too high of a pressure. The best way to solve it is with the pressure regulating sprinkler heads. Okay, let's see. I think that's all of that. So let's go back and reshare my screen here. There we go. And let's turn off the video. There we go. Okay. Now, if you've got too little pressure, that can be a problem as well. What you're going to want to do is try and lower the flow rate. Remember, the slower the water goes through the pipe, the less pressure you lose. So what you're going to do is use different or smaller nozzles. Make sure you're still using that, getting that head-to-head coverage out there. And again, this is another area where those stream rotor nozzles save bad irrigation systems. They fix that problem, whether it's the Rainbird or the Hunter ones you use, whichever one you like. But they use less water per gallon, per minute, per nozzle. So just by swapping out those, you'll drop the demand on that system down to about 33% of what it used to be. Very often that'll get you around the corner on a problem system that wasn't designed properly. Okay, the other option is divided into more zones. That means digging the yard back up, cutting into pipe, installing a new valve, running the pipe out to where those the sprinkler heads are going to split into a new zone are, and hopefully you have wire from where that sprinkler, that valve box is back to your irrigation controller. Larger pipe, that may do it, but again, you're still digging the system up. Or if you can, do that looping trick, if it's at all possible, kind of like what we showed you on the drip. But really your best, easiest non-digging option is right there. Okay, when it comes to controllers, don't worry about brand or model or anything like that. Think about the capabilities. Obviously, your station capacity, how many valves can I wire up to it? But think about run times. It's not as bad as it used to be, but just as recently as 10 years ago, a lot of those really low cost irrigation timers, they would have limitations on how long of a runtime you could program in there. Some of them would only let you program in 60 minutes maximum. I've got a 1 gallon per hour emitter on my shrub. I want to give it 4 gallons of water. I need a 4-hour runtime. If my controller can't do it, it's time for that controller to have an unfortunate accident. Calendar length is also another one that's not nearly the issue it used to be. Many of those controllers, and you may still have one of those old controllers on your house, will only let you get out to once every 7 days as the maximum interval in between water days. Even if all you have is grass and you put in a winter lawn, in December and January, you should only be watering that lawn every 10 to 14 days. So that 7-day calendar length on that controller is no good. You want a better controller. Think about how many start times it has available. That's how you're going to control the runoff. Even with these lower application rate nozzles like those stream rotors, you're not really going to want to run it an hour and 15 minutes all at once. What you're going to want to do is run well, if you're doing an hour and a half, do 3 30-minute cycles with about an hour and a half in between to let it soak in. So you would cycle for 30 minutes on a given water evening, let it set for an hour, cycle another 30 minutes on it, let it set for an hour, cycle your final 30 minutes on there. Now you've got good deep percolation on that root zone to get a nice deep root zone on your grass, but none of it's running down the street or ponding in the low areas. Think about the software. This means that means create a good, real watering schedule based on the science. And that's the amazing thing about that landscape watering by the number brochure is all the science and math and formulas, kind of like what I was talking to you about before with these things like, inches per hour precipitation rate and distribution uniformity. A really clever thing that they did with that is it is all in there, but you don't see any of it. They've hidden it all behind the scenes with just some very, very simple math to get you on your way. You've got to adjust it often, at least once a month. The Watering by the Numbers brochure recommends quarterly, and that's because unfortunately it's too many people only change their watering schedule twice a year. I've got my winter schedule and my summer schedule. I know it seems like it, but we do not go from our winter, say an average daytime high of 62 degrees, and then the very next day it's 118 degrees. We do gradually warm up, which gradually increases the water demand on the plants, but already starting in July, it needs to start going back in the other direction. But the weather changes every single day, and we've seen this just in the last couple weeks. The other day we had a high temperature of like 60 degrees and it was cloudy and it was windy and it was cold. The plants weren't using much water that day. Today we were almost 80 degrees. It was sunny most of the day and it was windy. So the plants on this given day used much more water than they did on that day a week ago. But who's going to go out there and adjust their controller every single day? That doesn't mean water daily, but adjust those run times a little bit or adjust the days between waterings a little bit to account for the fact that it's warmer or cooler. Nobody's going to do that. Well, except for the people that run the golf courses. They've got very sophisticated controllers where they can make all those adjustments very quickly at their computer back in the office. So this is where you may want to think about the smart controllers. This is exactly what they do. They measure the weather every single day. So they're looking at all the different parameters, how much sun, how much humidity, how much wind, and what are the temperatures, both high and low, to make those decisions on how much water have these plants used up on a given day. And when it gets to that halfway point, then it goes ahead and puts the water back out there. And that is important. You want to make sure whatever smart controller you get has the ability to adjust the days between waterings. Some of your low-cost options, all they do is adjust run times. So you set them up for summer watering. And then as you get into winter, it is running much less run time. So now that nice 8-inch watering depth you were getting on your lawn before, or not even just grass, think about your shrubs. Summertime, we're running it long enough to push that water 18 inches deep. And that is what drives how deep the water goes into the soil, is how long you run it. So if you start trimming back those run times all the way to December and January, you're no longer watering those shrubs 18 inches. You're still watering the same days between waterings, but now you're only watering those shrubs about 3 or 4 inches deep. So you need a controller that will adjust the days between the waterings. Okay, soil moisture sensors are out there, and I'm a big fan of them, especially on big, large monocot landscapes or monoculture landscapes. So the town of Gilbert is in the process of switching all of our large park controllers over to these because they're all mostly grass, especially our older parks. So very good for those homogeneous landscapes. So we actually have sensors buried out in the soil. And then when it gets dry enough, that's when the controller says, okay, if I'm allowed to water on this day at this time, I'm going to water that irrigation zone out there. When it comes to residential landscapes, if you've got lawns, you've got shrubs, you've got trees, you need 3 sensors. The ones that are sold as add-on devices to your existing controller can only have 1 sensor. So that means you got to put it in your lawn if you have one, which means now you're watering your desert trees as often as you're watering your lawns. So they really don't work well for, or easily, I should say, for most residential landscapes. So do remember on these smart controllers, these are not magical. This does not happen all on their own. Like I said, got to be able to adjust the frequency. They've got to be programmed and calibrated correctly for your irrigation system and your landscape. So you got to make sure you're not just following the defaults in there after it runs for a while. You do want to go in there and do some fine tuning on it because you're going to say, okay, my sprinklers, I think they put out this much water. And turns out you might be a little bit off on that. So the grass might be a little too wet, might be a little too dry. You want to go back in there and tweak those things. The other thing is people don't understand with these controllers is they are not set and forget. You've got to keep an eye on them and make sure they're doing what they're supposed to be doing. A water conservation professional here in the Valley bought one of these controllers and she went on vacation in April, first part of April. She was gone for 2.5 weeks. And when she came back towards the end of April, her landscape was in serious stress because that one used an on-site temperature sensor to measure the temperature. So when she opened up the controller at 5 o'clock in the afternoon at the end of April, that controller thought it was 32 degrees and it was watering as if it were 32 degrees. So you got to keep an eye on them. Now, one thing with these smart controllers is pay attention to your SRP electric bill. I don't know if Scottsdale has any information up on their website, but they run every year what they call a Water Conservation Expo. What that really is a way for you to buy one of these smart controllers at an instantly severely reduced price. So the manufacturer reduces the price a little bit, SRP kicks some in, and so does the irrigation distributor. Now, they've always been big events at one of SRP's facilities over in Tempe. Obviously, we can't do it this year, but they are still doing it virtually. And what will happen is you'll get a voucher to go to the irrigation supply store and get your controller. You have two options, and both of those options do that very important part of being able to adjust those days between waterings. With that being said, we are all set. So do we have any questions, Jill?
Right now, we do not. I'm just going to remind everyone there is a Q&A area, a little icon with two talk bubbles at the bottom of your screen. If you have any questions, I'm going to add a little bit to what Jeff said about the irrigation controller SRP Expo. So for those of you that are not in the South, we do also offer a rebate for irrigation controllers as long as they are WaterSense labeled. You can find that information on our website. If you go to scottsdaleaz.gov and then in the little search bar, you type in rebates, you'll get all of the information related to that. And it's not a bad deal.
Well, I didn't realize that. Is it APS service territory up north in Scottsdale?
Yes.
Okay. If you are going to do it again, make sure you're getting a timer that does a smart timer that adjusts the days between waterings. And if you go look at the SRP info, those two controllers that they're offering there, those are one of the two that you're going to want to get. For the people in the South that are on SRP for their electricity, you can buy that controller at an instantly reduced price. And if I'm not mistaken, they can then also apply the rebate to that cost.
Yes, that is a little known fact. So always a good reason to show up for workshops because you get pro tips like that. We do have some questions about recordings. This session is being recorded, and when we do a little snipping at the beginning to cut off that prior to attendees kind of being in the session, we will post that on our website. So you'll be able to view this at the same place that you registered on our workshops page. So we have another question, Jeff. Please repeat how often a winter lawn should be watered.
If you've put in winter grass and you've got it well established, in December and January, you should only be watering about every 10 to 14 days. That's the funny thing about that winter grass. It's a higher water use grass than our summer Bermuda grass, but it is used during cooler temperatures. But people just overwater the heck out of that stuff. They water it 5 days a week. And you'll see people out there, they can push that mower about 20 feet and then it's all clogged up with that wet, goopy grass they've created out there. So again, that landscape watering by the numbers brochure will show you how to do that quick little tuna can test to know exactly how many minutes to run your sprinklers. And what it's doing is it's getting you to apply 3/4 of an inch of water when you water. What that means is in June, you're going to need to do that every 3 days. But what happens is as you move into the fall, you're going to start moving those days between waterings out. And then obviously, if you are putting in a winter lawn, you're going to do it October, or actually recently we've been doing it more towards November because we've been staying much warmer, much later in the year than normal. But once you do get that established after about 14 to 18 days at the most, and during that time, you should already start making adjustments to how long you run it and how often you run it to develop those root systems 6 to 8 inches deep. Once you do that, you go back to that full run time that you're running in the summertime, but much less often. So in November, you might be at about every 7 to 10 days.
Awesome. Oops, sorry. Awesome. Thank you. We do have a question about where to get the watering by numbers brochure. So if you visit our website, scottsdaleaz.gov, and you search water publications in our search bar, that will bring up a link to all of our publications. So it's a good way to see the gamut of water conservation publications that are partnership with cities around the valley. And we have an additional question on how do you select an irrigation company for complete system installations?
That's the hard part. There are a lot of people out there that are landscape contractors. Many of them are licensed, many of them are not. So that's your first due diligence. Make sure you're hiring a licensed contractor and bonded and insured. So that way you're going to make sure your hind end is covered. there is no requirement for them to know any of the kind of stuff we were talking about here tonight, like as far as proper design with head-to-head coverage, and especially with all the weird math I was telling you about to measure the efficiency. They don't have to know any of that, but there is training out there that's available for them. And there's some really great training programs available here in Arizona. One of them is run by the Arizona Landscape Contractors Association. So they've got different training programs like the Arizona Certified Landscape Professional. They've also got some irrigation specific technician ones out there that are very good. There's some fantastic training, especially on the horticultural side at the Desert Botanical Garden through the Desert Landscaper School. And the contractor training program that us water conservation offices are involved in providing is called Smartscape. So you can go to smartscape.org and you can click on the button that says hire a pro. So the people that have gone through that training, and this is the caveat, we've trained them to do it right. So the hope is that they will be doing it right. There's contact information in there for them. One thing that we know about the database, and we just can't fix it on our own, is we've reached out many, many times to all the people on that list to get them to update their information as to whether I only do commercial work or I only do residential work. And if they don't update that setting, we can't do it for them because we don't know what it is. So unfortunately, if you put any of those search parameters in there, you're going to end up with very, very few people that show up. So the standard Smartscape course is 10 courses. It's everything landscape. It's plant selection. It's plant care. There's some irrigation design stuff. There's some watering stuff in there. There's some pruning stuff in there. Now, when it comes to irrigation, we also do an add-on module called Advanced Smartscape, which is an additional 3 6-hour-long courses on nothing but irrigation. And if they've gone through both of those, they will have that noted in there as well, that they've gone through Advanced Smartscape. Those are really the people you want to find.
Thank you, Jeff. There is one additional question on what is the link for replaying this evening's recording. That will be posted on the website. It should be available hopefully maybe middle of next week. I do also have the email addresses of everybody who's attended today, so I can send out an email when that goes live. So anybody who would like to revisit the presentation, or if maybe you missed some, that will be available for you to view.
And how long are you keeping that up, Jill?
Probably until our next workshop series. So until the fall.
There you go.
All right. I think then we have no additional questions. So thank you for all of you who stayed until the bitter end. And we really appreciate you attending our workshops. We do have another one tomorrow looking at drip irrigation, and then a few others in the following weeks on different topics. So check out our website if you haven't registered for those workshops. In our current structure, you do need to register for each workshop individually so that you get the correct link. And we look forward to seeing you all hopefully at the next workshops.